We are all familiar with real numbers, which are any numbers that exist on the number line. It could be negative numbers, positive numbers, zero, fractions, and these are real numbers. And now I'm going to go over something called complex numbers. And what a complex number is it has a real number and an imaginary number. An imaginary number you will not find on the number line. And I'm going to give an example. If we had negative 3 times negative 3, that would be positive 9. And 3 times 3 is positive 9. So we know that the square root of 9 would be plus or minus 3. Either one would be true. But what if I gave you negative 9? You would say that's not a real number. There's no number times itself that will give you a negative number. So now what I'm going to tell you is that this is an imaginary number. And the way to answer this question is to take that negative out of the radical. And by doing that, you put an I in front. You say imaginary 9. Imaginary square root of 9, which is imaginary 3i. So if I were to do another one, we know there's no number times itself that will give a negative number. So how do we get rid of the negative number? You put an I in front, and then you have I radical 100, which is just 10i, because that's a perfect square. And again, if we have negative 25, there's no number times itself. Get rid of this. And if I want to rewrite it another way, we could say negative 1 times radical 25. And now I'm going to tell you that the square root of negative 1 is I, imaginary radical 25, which is just 5i. And at this point, I'm not going to really discuss the applications of imaginary numbers. I'm just going to say if you drew a fractal, if you want to look up fractals, if you were going to become an electrician and you deal with circuits, you will deal with imaginary numbers. I'm not going to get into that for now. I'm just going to go over the rules. And right now, what I want to review is any number to the 0 power is 1. And you should know that because if we take a regular number like 5 over 5, we know that that cancels to be 1. And we know the rule with exponents. If the base is the same and they both have a base of 5, there's an exponent of 1. What's the rule? If the base is the same, you keep the base and you subtract exponents. So this is actually 5 to the 0, which is 1. And you're probably more familiar with that with x. If you have x over x, you could just cancel it and it's a 1. But the reason why is because you keep the base and you subtract the exponents, and it's x to the 0, which is 1. So we should all know any base to the 0 power is 1. Just like any base to the first power is itself. Now, the one that you have to memorize for the SAT is I squared is negative 1. That's a must. Just have that memorized. And now if we do by default I to the third power, let's see what we're missing because this is cyclic. We have 1 and negative 1, and we have I, so the missing value here would be negative I. So let's just say I wanted I to the 6th power. When you count, you don't start with 0, you start with 1. So I'm going to count by 1, and I'm going to go in a circle here. I'm going to go 1, 2, 3, then I'm going to go back up here and count the zeros, 4, 5, 6, and I get the negative 1. I'm going to do another one, I to the 7th. I could start with 1 and go 1, 2, 3, 4, 5, 6, 7, and the answer is negative I. So basically, if you have I to the 20, you could even make a circle if it makes it easier. I to the 0, I to the 1, I to the 2, and I to the 3. And if we want I to the 20, we could count 1, 2, 3, 4, and keep going, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's the same as I to the 0, and anything to the 0 power is 1. Now, since there are 4 choices, it might be easier to just take the exponent and divide by 4. So if we take 4 into 20, you get a 5. And what's the remainder? The remainder is 0. That remainder becomes the new exponent. So it's I to the 0, and anything to 0 power is 1. Now, why am I bothering doing this all by hand when I'm going to tell you there is a button in the calculator that just gives you the direct answer? Because this is on the non-calculator section of the SAT. So we do have to know this, and it only appears on the non-calculator section of the SAT. So here we go. We have I to the 17th. So instead of me counting around the circle, I'm going to do it this way. 4 times 4 is 16, remainder 1. So the remainder becomes the new exponent. I to the first power, anything to the first power is itself. Now let's just say I want to do I to the 99. 4 times 2 is 8. And then I know 4 times 5 is 20, so I have to put 4 times 4, which is 16. And then when I subtract it from 19, I get a remainder of 3. And I to the 3. Now, your calculator, you could just plug this in, but again, if it's on the non-calculated section of the SAT, you have to know, well, we could just say anything to 0 power is 1. First power is itself. We have to memorize I squared is negative 1. And then I to the third, by default, would be the negative I, because we have a 1 and a negative 1, and I, we need a negative I. I'm just going to do a few more of these. I to the 100 plus I to the 101 plus I to the 102. Well, 4 goes into 125 times, so I know it's remainder 0. Since this is 1 away from that, I know it's I to the 1, and that's 2 away from the original, so it's I to the 2. Or you could just, I'll do this one on the side. 4 times 25 is 100, but we have 102 here. And the remainder is 2, just like I said. This one you have to have memorized. It's negative 1. Anything to the first power is itself. So you have a 1 and a negative 1. And then you have an I. And these two cancel. So the final answer to this would be just I. You might see something like this, where we have a binomial, which is 2 terms, times another binomial. And I see a negative inside a radical. But it's a perfect square, so if I take the negative out, I could say 6i. And here, if I take the negative 49 out, I'm going to say 7i. Now I have to FOIL. I do 5 times 1, and then 5 times negative 7i, because you have to take into account the negative in front. Then you have 6 times 1, 6i times 1 is 6i. And then you have 6i times negative 7i, which is negative 42i squared. And this is the more popular one on the SAT. Now, the problem here, you have to remember that I squared is negative 1. So now you have 5, and then you have negative 35 plus 6. So the signs are the same. No, I'm sorry. The signs are not the same, so you're going to subtract. So, and again, if you have no calculator in this section, you would have to remember how to do this, which, you probably haven't done this in a while. You just subtract and keep the sign a little larger, which is the negative. And then negative 42 times negative 1 becomes positive 42. So the final answer is 47 minus 29i. Now, I teach for the SAT that if you have a binomial squared, your answer is going to be a trinomial, because when you do, I'll give an example, x plus 2, x plus 3, you would get x squared. I'm going to do this really quick because this is not the topic. You would get a middle term here. So you end up with 3 terms, so it's a trinomial. So sometimes I tell the kids on a standardized test, if you see a binomial squared, if there's only one choice with a trinomial, you just pick it and move on. And oops, I deleted it, but that's okay because it's not what we're going over now. But this is not true with imaginary numbers. 3 minus 7i squared, you have to write it twice. And we're going to do 3 times 3 and 3 times negative 7i, 3 times negative 7i. And then negative 7 times negative 7 is 49. But then I times I is I squared. Now the problem here, these are like terms, so you add them up, keep the I. But we have an I squared, and you have to know I squared is negative 1. So it changes this sign. It's positive 49 times negative 1, so it's negative 49. And then here, now we have like terms. The 9 and negative 49, signs are different. Subtract the numbers, keep the sign larger. And we actually get a binomial. And this is called A plus BI form. A is the real part, which is the negative 40, and the imaginary part is the negative 42i. So I'm going to do another one where I'm going to multiply. I'm going to do 3 times 5, 3 times negative 4i. 2i times 5, 2i times negative 4i, and I times I is I squared, because when you multiply, you keep the base and you add exponents. But once again, I squared is negative 1. So negative 8 times negative 1 changes this to a positive answer. And then we have here signs are different, so you subtract and keep the sign larger. So negative 12 and 10 is negative 2. Then you have 15 and 8, which is 23 minus 2i, and that's the final answer. Now, if you take a calculator and you put the mode in A plus BI form, and you could keep it in that form the whole year, it won't affect anything. You could just literally plug this in the calculator and it goes directly to the answer. Now let me show you how you would do the sum. Sum means add. You're going to add your like terms. You have a 5 and a 3, which is 8. And then you have a negative 3 and a 2. Signs are different, subtract, keep the sign larger, and then it's just going to be minus I. And again, don't get confused. It said the sum, so we're not foiling here. Foiling is when you multiply. And if you put this in the calculator exactly how I said, it also just gives you the answer. Here's another one. 3 plus 2i minus 5 minus 4i. Now here, whenever I see like a negative in front like that, I think of it like a negative 1 that I want to distribute. Negative 1 times 5 is negative 5. Most kids remember to do that, but they forget the second part, which is negative 1 times the negative 4, which is positive 4i. So when you subtract, if you have a binomial with a minus sign in front, I put the minus 1 and then I distribute. Then I remove the parentheses because I distributed it. And now I'm just going to look. I have a 3 and a negative 5. Those are my like terms. Signs are different. Subtract the two numbers. Take the sign larger. And then you have 2 and 4i, which is 6i. And then let's just say you have trouble with the whole math. You could draw on the SAT a mini number line. No big deal. Just draw one, and you could refer back to it if you have to, because you want to get the right answer. So if you start at number 3 and you want to hop back 1, 2, 3, 4, 5, you see it's negative 2. No big deal, because they know the mistakes you're going to make, and if you add it the wrong way, the choice will be there, and you need the question right, because it's really not that difficult. Now I'm going to talk about conjugates. Conjugate means change the middle sign only. So if I have negative 2 plus 3i, the conjugate would be keep the negative 2, and then you have to change the middle sign. So because it's a plus, I'm going to write minus, and then I'm going to put 3i. That's the conjugate. Now I'm going to do another one. If the original is 7 minus 5i, the conjugate would be keep the first sign and change the middle sign. So here it's a minus, so I have to change it to a plus, and then put the 5i. Here's another one. 1/2 plus 3/2 I. The conjugate would be 1/2 minus 3/2 I. And one more, negative 5x plus 4i. The conjugate will be negative 5x minus 4i. Now there is a button in the calculator that actually says conjugate, and if you put in the original, it will give you the conjugate. So why do we need to know the conjugate? We cannot have I in the bottom of a fraction. It's improper. So the easy one would be a monomial over a monomial, which is one term over one term. Now, to get rid of the I in the bottom, we would, if you have a monomial, you just multiply top and bottom by I. You have to be even, so whatever you do to the top, you do to the bottom. And when we do that, we're going to get 5i over 2i squared. Now, we know I squared is negative 1. And then we're left with 5i over negative 2. And we are done. I'm going to do another one. I'm going to do 2 plus 3i over 6i. Now, first of all, on top, we have a binomial because we have two terms. Terms are separated by the plus or minus sign, so we have one term here and one term there. But on the bottom, we only have a monomial. So all I have to do is multiply by I, and then I'll get rid of it. We do not want I in the bottom, so we have 6i squared on the bottom. And here we have to remember to distribute. 2 times I is 2i, and 3i times I is 3i squared. And then I know I squared is negative 1. So I'm going to rewrite this as 2i plus 3 times negative 1 over 6 times negative 1. So it's 2i minus 3 over negative 6. And I would leave it like that. You can separate, but if you separate, this goes in, so it'll be I over negative 3, and then this and this cancel to be half, but negative over negative is positive. I mean, if it's multiple choice and you don't see this as your choice and you only see this, you know, then you'd have to do it. But honestly, you could do this in the calculator and it will give you the answer as long as you put your binomial in parentheses and you put your monomial in one parentheses. Don't be chopping it up like that. You'd have to put it in one parenthesis like this, because the calculator knows the order of operations. But like I said today, this video is to show you how to do everything by hand. No calculator shortcuts at the time. Now I want to show you, what if you have a monomial over a binomial with an I in the bottom? Now, the way you get rid of it is multiplied by the conjugate, which you have to know is change the middle sign. And I'm going to go over why. I'm going to FOIL this out. First, outer, inner, last. And if you notice, the minus 6 and plus 6 will always cancel. The middle terms will always cancel. And then you're left with 4 plus 9 times I squared. And I squared is negative 1. So it ends up becoming 4 minus 9, which is negative 5. Now, instead of you doing all this FOIL, because the i's cancel, you could actually plug the whole bottom part in the calculator, the 2 plus 3i and 2 minus 3i, and you will get the negative 5. But once again, non-calculated section, the SAT, you have to know first squared minus last squared. So 2 squared is 4. He's the first guy. Now put the minus down, then look, 3i squared would be 3i times 3i, or 9i squared, and then you're up to this stage over here and you'd still get the negative 5. But then you have to remember on top that it's a monomial, which is one term, times a binomial, so you have to distribute to both terms with the sign in front. And this is the answer, but they're both divisible by 5. And I'm going to do it the shortcut way now. I'm going to multiply by the conjugate because I know I'm not allowed I in the denominator. So instead of me foiling, I'm going to remember first squared minus last squared. So I'm just going to look at the first guy, which is 3, and I'm going to square it. And I'm going to look at the 2i. And if I forget, I could write 2i, which is First, I'm going to write the minus sign down and then put 4i squared. Now, I squared is -1. So 9 minus 4 times -1. So it actually becomes 9 plus 4, which is 13. Now on top, you have to distribute 6 minus 4i. And here, the 13's prime, there's nothing to divide it by. You just leave it like that. Maybe they separate it because if they want it in a plus bi form, that's the a part and that's the imaginary part. One more. I'm going to do a binomial over a binomial. Well, the conjugate is change the middle sign. We want to get rid of the I in the bottom. The top is fine. I'm going to do first squared, which is 9. Then I'm going to put down the minus. Then I'm going to do last squared, which is I squared. And I know I is -1. So 9 minus -1 becomes 10. I like to do the bottom first. Now the top, I got to FOIL it. First is 12. Outer is 4i. Inner is 6i. And last is 2i squared, which becomes -2 because of that I squared. So 12 minus 2 is 10. And then 4i and 6i is 10i. And they're both divisible. You know, if I want, I could say 10 over 10 plus 10i over 10. So it ends up becoming 1 plus I. One last section. If you have x squared plus 9 equals 0, and you want to solve for x, you could subtract the 9. And now how do you get rid of a square? You square root both sides. And now we have a negative inside a radical. So we know it's 3i, but you always have to remember there's a plus and minus in front. So it's plus or minus 3i. X squared plus 2x plus 5 equals 0. Well, you would think that you could factor it, but 5 is prime and only 5 and 1 are the factors. So you could only get a 6 if you add them, or 4. Our middle term is a 2 here. When b, which is the number in front of x, is even, I personally prefer to complete the square. I'm not going to do complete the square with this. I'm going to do it the long way. I'm going to say a is the number in front of x squared, and if there's nothing there, you put a 1. B is the number in front of x, which is a 2. You have to include the sign in front. And c is a 5. Now, if it was the regents, the quadratic equation is given to you. If it's the SAT, you have to have it memorized. So I say there's a negative boy who's mixed up. He went to a radical party, and the boy is square because he missed out on 4 awesome chicks, and the party was over at 2 a.m. There's my formula for solving for the quadratic equation, and now I'm just going to plug in negative b plus or minus square root b squared minus 4ac all over 2a. So I'm going to do the middle part first. I'm not going to plug it in the calculator with the radical sign. I'm just going to do 2 squared minus 4 times 1 times 5. So it becomes 4 minus 20, but I'm just going to do it in one swoop, and I get -16. So I get radical -16 here. So I have -2 plus or minus radical 16 over 2. Now, we can't have negatives in front of a radical, so it's an I, radical 16. And 16 is a perfect square, which is 4. So the answer is -2 plus or minus 4i over 2. They're both divisible by 2. So if we want to separate it, it's -1 plus or minus 2i. The roots with imaginary numbers are always conjugate pairs. Very important concept. So if one root is 2 plus I, they don't have to give the other root because I automatically know it's 2 minus I. That's just for your information. Now, let me give you another one. X squared plus 7 equals 2x. Well, you have to set equal to 0. You have to put it in standard form. So when I bring the 2x over, it's the opposite sign. You know, I could do it slowly here, minus 2x like that. And I'm going to put it in descending order. So A is 1, B is a negative 2 because it's a sign in front, and C is 7. So if I want to solve for the zeros or solve for the roots, it's negative B, so I have to change the sign, negative B plus or minus square root of B squared minus 4 times A times C all over 2A. And then I have 2 plus or minus, I'm going to do this part in my calculator, and if you don't put the negative 2 in parentheses like this, you'll get the wrong answer, because negative 2 squared in your calculator would be negative 4, because it's saying take the 2 squared and negate it. But that's not what this is saying. This is saying negative 2 times negative 2, and any negative number times another negative number is a positive number. So enter it in the calculator exactly how I have it here. So I'm going to get 4 minus 28 over 2. So again, I'm getting 2 plus or minus negative 24 over 2. Now 24, to break it up into perfect squares, would be 4 times 6. So first I'm going to get rid of the negative by putting an I in front, and then the square root of 4 is 2. So 2I rad 6 over 2 here. And then you're not touching the inside of the radical. You keep that. You could only do the out divided by the out. So the 2 divided by 2 cancel here, but you can only do that if it cancels to both parts of the binomial. So we can do that. And if it makes it easier, separate it. Do 2 over 2 plus or minus 2I rad 6 over 2. And then you cross it out and you get 1 plus or minus I rad 6. That's your A plus BI form. Now, a hint to know that it's not factorable is when it says, to solve for the answer and express in A plus BI form. It's telling you it's a complex number. It's not a real number. So, you know how when you're plotting a graph with a polynomial and they want the roots, like here, maybe the numbers are 3, a 2, a 1, I know I didn't draw it to scale, and a negative 1 here. These are the roots. They're the real roots because they're on the x-axis where y is 0. But an imaginary root will never hit the axes. So here I have 2 real roots, and maybe I have an imaginary root. Maybe over here there's an imaginary number that exists, but it's not going to touch the x-axis. So that's very important. I'm going to do one complete the square. I have a factoring video that explains the reason why we use these steps. It's explained very thoroughly, and I don't want to put it on this video. I'm just going to write the steps out. And I teach ABC for complete the square. Is A equal to 1? Yes. That's very important. Then, I only do this if B is even, which it is. But you're going to bring C over. C is the constant alone. So the opposite of plus 9 is minus 9. So I'm going to write x squared minus 4x plus blank equals negative 9 plus blank. Now I got to complete the square. I got to cut B in half and square it. That's what I'm adding to both sides. So, and I write it right on top really small. Negative 4 cut in half is negative 2, but when I square it, it's always a positive number because negative times negative is positive. It ends up being a 4. That's a coincidence. That's the same as B here because negative 2 squared is 4. But when you do to the left, you do to the right because it has to be balanced. Now, this could be factored now. This is a perfect square trinomial, but I don't even have to use my brain. That's why I wrote the half of B here because I just bring it down. And, if I did x squared, it'd be x and x. Like if I did do it the long way, but I'm not here to really show this. 2 and 2 ends in a positive, same as middle, but I skip that step, go right there. And here I get negative 5 because the negative 9 plus 4 is negative 5. Now, how to get rid of a square? You square root both sides. Then you're just left with the inside equal to I rad 5 because you can't have a negative in a radical. You got to pull it out. There's always a plus and minus in front. And then to isolate the x, you bring the 2 over. And then you get x equals 2 plus or minus I rad 5. That's in lieu of doing the quadratic equation. So I'll do one more. I personally don't like solving something without really explaining why, but I just want to finish this video. And like I said, it's all on my factoring video, which is on my website. So here B is even. It's a number 8. So ABC, is A equal to 1? Yes. Bring C over. So the opposite of plus 25 would be minus 25. Now I have to make a new trinomial that's a perfect square. And I know half of B is 4, and when I square it, I get 16. Now that that's a perfect square trinomial, I could just write it like this. It's going to be the binomial twice. And oh boy, negative 25 plus 16. I don't have a calculator on me today, so I'm going to show you what to do. The signs are different. You subtract, and you keep the sign of the larger number. So it's negative 9, because this number is bigger. Now, how to get rid of the square? You square root both sides. Then you're just left with the inside. And this happens to be plus or minus 3i. But then you have to bring the 4 over. So x equals negative 4 plus or minus 3i. And notice it's a conjugate pair. Like I said, they'll always be conjugate pairs. Now, how can you tell? How can we tell that it's going to be an imaginary number? What's inside this radical here is known as the discriminant. The discriminant is just the b squared minus 4ac. If this number happens to be equal to a negative number, we know we do not have real roots. We have imaginary roots because you can't have a negative number inside a radical. So a fast check, if you're doing something quickly, let's just say I had x squared minus 2x plus 8, and I want to know if it's going to be an imaginary number. I could just do b squared minus 4ac without even doing the work. And they do ask this concept on the SAT. Here I'm getting a negative number. Who cares what the number is? I just know it's a negative number, so that's the imaginary one. That's going to have no x-intercepts. It's not going to cross the x-axis, because if it did, it would be a real root, and these are not real roots. I hope this helped. I would like to get up a video on how to use the calculator, but that's in the future.